So, to replace our cancelled lecture on Monday 16th of October, I'm going to deliver the material on circles through the medium of YouTube. So this is a new section where we're going to write the equation of a circle in the following form. S of xy is x squared plus y squared, which you recognise, plus 2ax plus 2by plus c. And to be precise, a, b and c are real numbers that can be positive or negative or zero. If you're familiar with completing the square, and of course you should be, because that was assignment 0, you can see how this expression can be rearranged. We complete the square twice, once for x and once for y. So this looks like x plus a squared, and then we have to subtract an a squared plus y plus b squared, and so from that we have to subtract a b squared, and then we add in the c. Therefore, s of xy equals 0 is the equation of a circle. And so sometimes it helps to put it in the form at the top of the page. Other times we use the more familiar x squared plus y squared equals r squared. And so from the first form we see that the centre of this circle is the point minus a comma minus b, and its radius is not c squared, but it is the square root of a squared plus b squared minus c. Okay, let's do some examples of this. Examples 1.14. If s of xy is the expression x squared plus y squared minus 6x plus 8y plus 21, then what do we know about the equation s of xy equals 0? Well, in contrast to some of the strange examples we did in the previous lecture, this really is a circle, and the parameters compared to the general form are 2a is equal to minus 6, 2b is equal to 8, and c is 21. And so the centre is at 3, minus 4, and radius is the square root of 3 squared plus 4 squared minus 21, which is 2. Clearly I ignore the negative root. Another example. X squared plus y squared plus 5x minus 1. So what happens if I write the equation s equals 0? Well, this is again a circle, but just with b equals 0. So the centre is at minus 5 over 2, comma 0. The radius, call it r, it's kind of traditional. Square root 5 over 2 squared minus 1 is half square root 29. So that's fine. Another example. What happens if I have a prefactor in front of the x and y? Clearly, those two prefactors must be the same, the 5 and the 5, else it wouldn't be a circle. But to determine the properties of the circle, where we are equating s to 0, I can just take out that factor of 5. And then we proceed as before. So we can show that s of xy equals 0. Is a circle with centre minus 1, comma 6/5, and radius square root of 1 squared plus 6 over 5 squared plus 2/5, which is 1/5 times the square root of square root of 71. One more example, and of course you're probably thinking it's too good to be true that all of these examples I happen to choose coefficients that did result in a circle. So here's an example: x squared plus y squared plus 4x plus 6y plus 15. All of those plus signs probably tell you that we might want to worry when I equate this to 0. This appears to be a circle with centre minus 2, comma minus 3. But when we calculate the radius, 4 plus 9 minus 15, which is the square root of a negative number, So this does not describe a circle. So it's not the case that you can just write down any coefficients you want in this form for S and get a circle. So now we're going to use this form of the equation to write down the equation of the tangent to a circle. And so the idea is the following. There's a circle relative to some axes labelled by x and y. The circle has a centre, let's call it Q. Consider the circle with centre Q, and I'm going to call the centre coordinates minus A, minus B, so that when we write down the equation of the circle, they appear positive. And radius R equals A squared plus B squared minus C. So I'll write it like that for the same reason. So I'm going to label it with the letter S and write its equation as x squared plus y squared plus 2ax plus 2by plus c equals 0. Now, choose a point on the circle. Let's call it P, with coordinates x1, y1. And we seek the equation of the tangent to the circle through P. Tangent. And the clue, of course, is that the slope of the tangent is perpendicular to the radius between Q and P, which has length R. So, if the point with label P and coordinates x1, y1 lies on the circle, then when we evaluate S at x1, y1, we must get 0. The tangent to the circle at P, which is what we'd like to find, is perpendicular or orthogonal to the line segment PQ, or if you prefer, the line through P and Q. And that tangent goes through P. So that's all the information we need to define the equation of a line. So, the slope of PQ is the difference in the y coordinates of the 2 points, y1 minus b, divided by the difference in the x coordinates. Therefore the tangent has slope minus the reciprocal of that. So the equation of the tangent, well, it must go through y1, it must have slope as given there, and it must go through the x-coordinate x1. So we just need to rearrange that into general form. We're going to have x times x1 plus a plus y times y1 plus b plus a bunch of constants. Can we simplify this? Well, we haven't used the information that s of xy y1 equals 0. What does that tell us? That tells us that x1 squared plus y1 squared plus 2a x1 plus 2b y1 plus c equals 0. So I'm going to substitute x1 squared plus y1 squared equals minus 2a x1 minus 2b y1 minus c. So this gives me x times x1 plus a plus y times y1 plus b plus a x1 plus b y1 plus c is 0. And just as a sanity check, note that this is linear in both x and y. So it really is a line. Let's put a box around this, and we can call it definition 1.8. In standard form, the equation of the tangent to a circle at x1, y1 is this. And you will find that that is reprinted on the front of the examination questions. So you need to understand where it comes from and how to use it, even if you don't remember all the details of the derivation. So let's do an example of how to use it. Find the tangent to the circle, which we'll call S, that has equation x squared plus y squared minus 6x minus 3y minus 5 equals 0 at the point 1, comma, minus 2. And for the skeptics, I'm first going to check that the given point, 1 minus 2, is on the circle. How do I do that? Well, I just substitute x equals 1, y equals minus 2, 1 squared plus minus 2 squared, minus 6 plus 6 minus 5 does indeed equal 0. So now we're going to set x1 equals 1, y1 equals minus 2, a equal to minus 3, b equal to minus 3 over 2, and c equal to minus 5, in the equation of the tangent that's at the top of the page. So that gives me x times 1 minus 3 plus y times minus 2 minus 3 over 2 minus 3 plus 3 minus 5. So just simplify that. Minus 2x minus 7 over 2y minus 5 equals 0, or multiply 3 by minus 2, it looks a bit prettier. And there we have a straight line equation, which is indeed the tangent. I just check for common factors, but 4, 7 and 10 are prime, so that's fine. Having found the tangent to a given circle, we can also calculate something which is known as the tangential distance. Which is a slightly different measure than radial distance of a point from a circle. So if I have a circle and some point, I'll call it R, with coordinates x2 and y2, then the tangential distance is not the distance to the centre, it's the distance along the tangent to the circle. And so let's call P the point where the tangent meets the circle. And of course there are actually 2 points where a tangent to the circle meets, goes through R, the other one being there, but the tangential distance is the same. So for the sake of clarity, I'll remove that. And this is the tangential distance. So let's write this as a definition. the distance of a point R with coordinates x2, y2 from the point P at which the tangent through R touches the circle S with general equation x squared plus y squared plus 2ax plus 2by plus c equals 0. That's the circle with centre minus a comma b, which we called Q. It's called the tangential distance of R from the circle S and the formula is simple. We evaluate the equation of the circle at the point. Of course, if R is not on the circle, then this is something non-zero, and we take a square root. This may not be immediately obvious, so let me show you the construction. And the idea is that we have a right-angled triangle with a right angle at P. So we want PR, but let's square it. That's the tangential distance squared. And this is QR squared minus PQ squared. Well, PQ is just the distance R. And RQ squared, we can use the Euclidean distance. So this is x2 plus a squared plus y2 plus b squared. And this is r squared, and we're going to write r squared as a squared plus b squared minus c from the general equation of the circle. Let's expand the brackets. x2 squared plus y2 squared plus 2ax2 plus 2b y2 plus a squared plus b squared minus a squared minus b squared plus c. And this is precisely what we wanted, S of x2, y2. Good. Some caveats. This does not hold if R is inside the circle. And perhaps now I can explain the point. When we wrote the equation of a line as f of xy equals 0, we then had a test to see which side of the line a certain point was. Now we have a test to see if a point is inside or outside a circle. We can evaluate the tangential distance, and if it's positive, we know that the point is outside the circle. If it's 0, we know that the point is on the circle, and if it's negative, then we know that the point is inside the circle. So, although it is true that S of x2, y2 is less than 0 if r is inside the circle, in this case. So, choose a point, choose a circle, S of x2, y2 less than 0, r is inside the circle, S of x2, y2 equals 0, r is on the perimeter of the circle, and if S of x2, y2 is positive, r is outside the circle S, with tangential distance square root of x2, y2. A couple of examples. On point 16, given the circle S with equation x squared plus y squared minus 3x plus 5y plus 2 equals 0, determine if the point 2, 1 is inside or outside the circle. So let's define our function S of xy to be x squared plus y squared minus 3x plus 5y plus 2, because the chances are it's not going to be equal to 0. S of 2, 1 is 4 plus 1 minus 6 plus 5 plus 2, which is 6. So 2, 1 is outside the circle. Since this is positive, if we were asked for the tangential distance, of course we'd be able to give it. Its tangential distance is square root of 6. One more example with inequality, because I suspect practice at inequalities is no bad thing. For which values of C is the point C, minus 1 outside the circle S with equation x squared plus y squared minus 3x plus 5y plus 2 equals 0, which is an equation you might recognise from the previous question. It's not compulsory to draw a picture, but I think it helps. At least it helps me. So the circle has centre 3 over 2, comma minus 5 over 2, and radius 9 plus 25 minus 2, a bit more than 5. Oops. Maybe something like that. And we're interested in these points and these points on the line y equals minus 1. So we'll see how close to that we get when we do the problem algebraically. So again, just as we do with lines, let's be careful to define the function we want. S of xy is x squared plus y squared minus 3x plus 5y plus 2. And now we evaluate S of c, comma minus 1. So this is for all the points on this horizontal line. And we're going to get a quadratic for c. So we want this point to be outside the circle. So I'm trying to explain what I'm doing in words, because it's always a good way of picking up marks as well as clarifying your own thought processes. We need this to be positive. But if I equate it to 0, I can use the quadratic formula. The numbers are not particularly nice, but one of them is positive, 3 plus root 17 over 2, and the other is negative. So C must be between, we need C less than the negative 1, and C greater than the positive 1. And we're done. So on Thursday we'll start polar coordinates.